The general form of the tangent function is the following, and you should notice that the general form of the tangent function looks very similar to the general form of these two sinusoidal functions, sine and cosine. Now, the effect of the values a, b, c and d, the effect they have on this function, will be reviewed again in this video to refresh your memory. So here we have the graph of a tangent function. And you'll notice this graph in blue lies between this vertical asymptote and this vertical asymptote. Now, because the tangent function is a periodic function, what we have here is one cycle of the tangent function. And this one cycle, or this shape here you see, will repeat itself throughout. And the vertical asymptotes will also repeat themselves throughout. So the period is how many degrees or radians it takes to complete one cycle. Now let's look at the values for A, B, C and D and what the effects are on the graph. So the value of A affects the graph by causing a vertical stretch or compression. So if you look at this graph in pink, you can see a vertical stretch and a vertical compression taking place. Now the value of B affects the period. It causes a horizontal dilation. So if you look at this graph in pink here, you can see it expanding in the x-axis and compressing in the x-axis, and the effect it has on the period as well. Now the value of C produces a phase shift. This is a horizontal translation. So if we look at this graph in pink, you can see what the effect C has on the graph. So it moves to the right, or it could move to the left, depending on the sign of C. And the value of D produces a vertical shift or a vertical translation. So again, if we look at this graph in pink, we can see a vertical translation taking place, moving up or down, again, depending on the sign of D. Now there are some conditions for A and B, and that is A cannot equal 0 and B cannot equal 0. If we want to find out the period, this is equal to pi over the absolute value of B. And two consecutive vertical asymptotes can be found by solving the equations bx plus c equals minus pi over 2 and bx plus c equals pi over 2. So you'll notice bx plus c is what we have here in the bracket there. So if you make this equal to minus pi over 2 and pi over 2 and we solve them for x, we'll find the equations of these two consecutive vertical asymptotes. Now, if a is strictly less than 0, that is, A is negative, then we'll have a reflection in the x-axis. And if B is strictly less than 0, so that is B is negative, then we'll have a reflection in the y-axis. So here are the steps to draw the graph of a tangent function. So step 1, find the period. Step 2, find and plot the vertical asymptotes. Step 3, find and plot the x-intercept. Step 4, produce a table of values and plot the points between the asymptotes and the x-intercepts. So in example 1, we're asked to locate the vertical asymptotes and sketch the graph of y equals tan 2x. So for step 1, we'll try and find the period first. Now, the general form of the tangent function is this. So if we now compare the two, and I've just highlighted this bit in blue, we can see here that b is equal to 2. So now that we know b is equal to 2, to find the period, we use this formula here, pi over the absolute value of b, which will give us this over here. And we know the absolute value of 2 is just simply 2, so the period is pi over 2. Now for step 2, we'll be finding the vertical asymptotes. Now if you recall, these are the two equations we need to solve for the values of x to find out what the vertical asymptotes are. Now if you can see bx plus c is just simply this bit in the bracket. And this bit in the bracket is equivalent to 2x in this particular question because b is equal to 2 and c is 0. So this whole part in the bracket can be replaced with 2x. So I can replace bx plus c here with a 2x and the bx plus c here with a 2x. And now we can solve. So to isolate the x term here, I divide both sides by 2. And I can do the same thing here to isolate the x term here. I divide both sides by 2. And when I do that, I get the following. X equals minus pi over 4. and x equals pi over 4. And these are our two consecutive vertical asymptotes. So for step 3, we want to find the x-intercept, and we do this by finding the real zeros of the function tan 2x. We can find the real zeros by equating tan 2x as being equal to 0 to give us this trig equation which we need to solve. So we want to undo the tangent function, and we can do that by taking the inverse of tan to both sides, and that will give us 2x is equal to the inverse tan of 0. Now the inverse tan of 0 is simply 0. And we can see if we divide both sides by 2, we can isolate the x term to give us x equals 0. This tells us that the x-intercept is at 0, 0. Now, a shorter way to find the x-intercept for step 3, let's just recall our general form for the tangent function. Now, if the value of d is equal to 0, this tells us there's no vertical shift. So if there's no vertical shift, then the x-intercept lies in the middle of the two consecutive vertical asymptotes. So we have these two asymptotes here. I want to find out the middle value. So how do I do that? Well, we simply add the two values together and divide them by 2. So minus pi over 4, add pi over 4 will give me 0. 0 divided by 2 will give me 0. So we can see a quicker way of finding the x-intercept is by finding the middle value if there is no vertical shift, and there is no vertical shift when d equals 0. Now we have step 1 to step 3 summarized over here. Now step 4 is to produce a table of values. So for this we'll only be using step 2 and step 3 essentially. The period pi over 2 that we found out we'll use later on when we have the graph. So we have a table of values like this. We'll input our vertical asymptotes first. So we have x equals minus pi over 4, which will go here, and x equals pi over 4, which will go over here. Then in the middle we have the x-intercept, which we know is 0, 0. So now the intermediate point here is the midpoint of the x values of this vertical asymptote and this x-intercept. So the x value here is minus pi over 4, and the x value here is 0. So we want the midpoint of that. So how do we work this out? Well, we simply add these two values together and then divide by 2. So minus pi over 4 plus 0 gives me minus pi over 4. Divide it by 2 and it'll give me minus pi over 8 as the x value. Now, to find this value here of y, we simply substitute this x value into this function, and that'll give us minus 1. To find this intermediate point, we want the midpoint of the 0 here and x equals pi over 4 over here. So again, we add the two values and then divide them by 2. So 0 plus pi over 4 is pi over 4. Pi over 4 divided by 2 gives me pi over 8. And again, we substitute this x value into this function to give us this y value of 1. So now that we have our table of values for the key points or the key bits of information we'll need to graph y equals tan 2x, we can produce the graph. So we have a vertical asymptote at x equals minus pi over 4, which will go over here. Another one at x equals pi over 4, which will go over here. And then these 3 points we can simply plot into our graph like so. And then we'll draw a smooth curve going through these 3 points like so. And you can see that this is one cycle of this tangent function, tan 2x. So the period here is the distance between minus pi over 4 and pi over 4. And you can see that's pi over 2, which agrees with what we have here. So we have some certainty about how accurate our working is. So now that we have one cycle, we'll sketch in one cycle to the right and one cycle to the left. So this will be a repetition of what we have here. So I'll plot the asymptotes in first. So we have pi over 4 as being the asymptote over here. So we'll simply add pi over 2 to give us an asymptote at 3 pi over 4. And over here we'll subtract pi over 2 to give us an asymptote at minus 3 pi over 4. And now we're set to produce another cycle on the left hand side like so, and another one over here like so. And this is the graph of y equals tan 2x. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
So for example 2, we have a similar question to example 1, except now we're asked to sketch the graph of y equals minus tan of x over 2. So for step 1, we'll find the period. But before we do that, we'll write down our general form, and then I'm going to highlight some key bits of information there so we can make a comparison here. So you can see here there's a -1 in front of the tan, so that tells us A is equal to -1. I'll write that over here. And we can see B is equal to a half, which I'll write down over here. And then to find the period, we'll use this over here. We'll substitute or replace the B with a half to give us this. And then this will simplify to 2 pi. So the period is 2 pi for this function. So step 2, as previously, we'll be finding the vertical asymptotes by solving these two equations. So again, we know bx plus c, the equivalent over here is x over 2. So I'll be replacing bx plus c with x over 2. So bx plus c is replaced with x over 2 over here, and the bx plus c is replaced with the x over 2 over here. Now, to isolate this x term, I need to multiply both sides by 2 to give me the following, x equals minus pi. And to isolate this x term, I'll multiply both sides by 2 again to give me the following, x equals pi. So these are our two consecutive vertical asymptotes. So for step 3, we want to find the x-intercept. Now we can find an x-intercept by finding the real zeros of this function. We can do that by setting this function equal to 0 and then solving the equation. However, if you recall previously, we know that the value of d is 0, so there is no vertical shift here. So the x-intercept lies in the middle of the two consecutive asymptotes. So we have x equals minus pi and x equals pi. To find the x-intercept, we'll simply add these two values together and divide them by 2. So minus pi plus pi is 0. 0 divided by 2 will give me a value of 0. So our x-intercept is at 0, 0. So for step 4, we'll produce a table of values like we've done previously. So we have vertical asymptote x equals minus pi over here and x equals pi over here, as we know from this information that we worked out earlier. And then we have an x-intercept of 0, 0 over here. And as we recall, the intermediate point is the midpoint of minus pi and 0. So when we work that out, we'll get minus pi over 2. To work out this y value, I substitute this x value into the function to give me y equals 1. Now, to find this intermediate point, I'll do the same thing. I'll take this x value of 0, add it to pi, which gives me pi, and divide by 2 to give me pi over 2. And again, if you substitute this x value into this function over here, we'll get a value of y equals minus 1. And this completes the table we're looking for. So now that we have a completed table of values, we can now produce the graph. So we have x equals minus pi as being the first vertical asymptote, then x equals pi, which is another vertical asymptote over here. We can simply plot these 3 points in like so, and then draw a nice smooth curve going through these 3 points like so. So this gives us one cycle of this tangent function here. So we know the period is 2 pi, and we want cycles to the right and one more cycle to the left. So we know the period is 2 pi, so starting from this vertical asymptote, we'll simply add 2 pi to give us a vertical asymptote at 3 pi, and then subtract 2 pi to give me a vertical asymptote at minus 3 pi, and then we simply draw in what we have in blue over here to give us another cycle here, and then one more cycle on the right hand side. And this completes the graph of y equals minus tan of x over 2. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. So in example 3, we'll be sketching the graph of a cotangent function. So we're asked to locate the vertical asymptotes and sketch the graph of y equals cotangent of x over 3. So for step 1, like the previous one, we'll be working out the period. But before we do that, we want the general form of a cotangent function, which is what we have here. And you'll recall this is very similar to what we have for the general form of the sine function, the cosine function, and the tangent function. So you can see a value for A, B, C, and D. So now, if I highlight the key bits of information here, we have x over 3, and make a comparison, we can see that B is equal to 1 over 3. Now to work out the period, we have the exact same method of working out the period as we did for the tangent function. It would be simply pi over the absolute value of B. So if I replace this B with 1 over 3, we get the following here, and this will simplify to 3 pi. So this cotangent function has period 3 pi. Now for step 2, we'll be finding the vertical asymptotes for the cotangent function. However, the equations we must solve for this are the following. So they differ slightly from the tangent function, so we must make sure we make a note of this. So again, as before, bx plus c is this part in the bracket. So if we make a comparison to our function over here, bx plus c is equal to x over 3. So we can see b is 1 over 3, and the value of c is 0. So I'll simply replace the bx plus c with x over 3. So over here, bx plus c replaced with x over 3 gives me the following over here, and the bx plus c replaced with the x over 3 gives me the following over here. So when we solve these two equations, we get the following: x equals 0 and x equals 3 pi. And these are the two vertical asymptotes, or consecutive vertical asymptotes, for this cotangent function. So for step 3, we'll be finding the x-intercept. So we want the real zeros of this function, and we can do that by equating this function equal to 0. And we can solve this by using this identity over here. Cot theta is equal to cos theta over sine theta. Again, however, we know because d is equal to 0, so we can see the value of d is equal to 0 here, there is no vertical shift. That means the x-intercept lies in the middle of the two consecutive asymptotes. So how do we find out the middle value of 0 and 3 pi? We add them together and divide them by 2. So 0 plus 3 pi is equal to 3 pi. 3 pi divided by 2 will give me 3 pi over 2. So we can see the x value is 3 pi over 2, and our x-intercept is at 3 pi over 2, 0. So now for step 4, we'll be producing a table of values. So these two key bits of information, the vertical asymptotes and the x-intercept, will input into this table here. So we have a vertical asymptote at x equals 0 and a vertical asymptote at x equals 3 pi. The x-intercept is 3 pi over 2, 0, as we worked out earlier. Now to find the intermediate point, we want the midpoint of these two x values. So between this vertical asymptote and this x-intercept, we want the midpoint. So we'll do 0 plus 3 pi over 2, which gives me 3 pi over 2, divided by 2 to give me 3 pi over 4. And then we'll substitute this x value into this function to give me the y value of 1. And again, we'll do something similar for this intermediate point. We'll add the x value 3 pi over 2 to 3 pi over here, and then we divide it by 2 to give us the following 9 pi over 4. We substitute this x value into this equation over here, and we'll get y equals minus 1. So with our completed table of values, we can now make our graph. So we have a vertical asymptote at x equals 0, which goes over here, and another vertical asymptote at x equals 3 pi, which goes over here. And then we'll just simply plot these 3 points in as follows, and we'll make a nice smooth curve going through these 3 points. So this is one cycle of the cotangent function, which has a period of 3 pi. So we want to make one cycle on the right and one cycle to the left. So we'll simply add 3 pi to 3 pi over here to give us a vertical asymptote at 6 pi. And then we'll subtract 3 pi from 0 to give me a vertical asymptote at negative 3 pi. And then we can plot in our cycles to complete the graph. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.